Welcome friends to the Formula Engineering classroom, and in this lecture we will discuss the hydrostatic forces on curved submerged bodies. Okay, so you can see here I draw a diagram of a curved flat surface that is completely submerged under a fluid. So here is the level of fluid. This is in 3D system or in 3 dimensions. So I draw this diagram. So now we want to calculate the forces on this curved surface. So to calculate the force in this curved surface, first let's suppose if we are saying we are considering a strip over here on this curved surface. Okay, we are considering a strip on this curved surface, and let's suppose the area of this curved surface is dA, and this curved surface is making, this is the tangent here of this elemental area, and this is making an angle, let theta. Okay, this is making theta angle here. So let in this case, obviously in this case this elemental area has some distance from the free surface of fluid. So let's suppose we are saying this is y, and I'm saying this is y here. Okay, so the pressure intensity at this depth on this curved surface will be P. Okay, so and that pressure intensity will be normal to this one, so we can draw like that. This is this is the pressure intensity P here, and by the hydrostatic law we can write that is P is equals to rho G Y or WY. Okay, now so what will be the elemental force that will act on this elemental area? So obviously we can directly calculate that is the elementary force dF will be equals to the pressure intensity, that is P, into the elemental area dA. So this is the force that is acting over here. So let I'm drawing this force. Obviously this will also be the normal here and along the same line here, and let I'm saying this is dF. Okay, so dF is the elementary force here. So to solve this type of problem, we have to resolve this force in horizontal and vertical direction. Okay, so let this force has two components. One is the horizontal component, this is the horizontal component, and let this is the vertical component, or actually you can say here this is the vertical component. So let I'm saying this is DFH. Here H is indicating horizontal, and this is DFV, that is vertical component. So obviously in this case the tangent over here, this is the tangent, that is actually this one. This is making an angle theta. This is theta here. So if this is theta, this is 90 minus theta. So obviously in this case this will be theta here. Okay, so what will be the vertical component of this force? So we can write vertical component of this force, so we can resolve along the angle. So this will be cos theta, so we can write this is dF cos theta, and the horizontal component of this force we can say that is against the angle, so we can write this is dF sin theta. Okay, now so by calculating these two components we can calculate this dF. Obviously this dF is the resultant force. This is due to the vertical component and the horizontal component. Okay, so if we can calculate by integrating the total vertical and horizontal component, then we can easily solve this problem. So we can say that there is Fv, we can write Fv will be, we can integrate this one, that is dF cos theta, and Fh will be dF sin theta, and the resultant force that we can say that Fr, that we can calculate by squaring them. This is squaring the vertical force component and adding to it the square of the horizontal force component, so we'll get the resultant force that is acting over this curved surface. Okay, But there is second method. So before discussing the second method, let first we try to understand how the pressure is going to be distributed over this inclined surface. So let here. So obviously, let's suppose if we know that is at this point it has some depth from the free surface, so there is some pressure intensity. Let's suppose this one, and this is at the same level, so it will be same here. So we can say that this one. So this is the pressure intensity that is normal to this curved surface. Okay. So as the depth is increasing, the pressure intensity is also increasing. Okay. So I think this is the deepest point. So here the pressure intensity will be highest. So I'm drawing this one, and obviously this level and this whole level is same here, so this will also be same here. So this is the pressure intensity over here. Okay, so the variation of pressure will look like somehow this one. The pressure keeps increasing, and obviously this is normal to this surface over here. Okay, so this is the pressure variation over this inclined surface. Okay, to solve this problem, we first calculate the horizontal force, and to calculate the horizontal force we will take the projected area of this curved surface. Let's suppose we are here and we are viewing this surface from this side. So I think in that case the projected area of this curved surface will be this one, this rectangle here. You can say this one, this rectangle. Okay, this is the projected area of this curved surface. I think we can calculate the force or hydrostatic force on this projected area normally as from our previous information. Okay, so let me erase this one. So in this case, just a minute. So I think the pressure variation over this projected area, we can draw this one like that. Obviously the diagram is going to be congested here, so but let's try to explain this one. So this is the pressure intensity over this projected area. Okay, and this is the pressure intensity over this one. So I think we can calculate easily what is the pressure force or hydrostatic force on this projected area. Okay, you can see here the diagram again obviously going to be congested here. So this is the pressure intensity, that is distribution of pressure over this rectangular projected area. So obviously in this case to calculate, we know that is, we can say that is force F will be equals to WA YC. Okay, as a previous formula. So first of all we want to calculate the YC of this projected area. Obviously what is YC? YC is the distance of center of gravity of this projected area from the free surface. Okay, so let's suppose around here is the center of gravity, so this is the YC. Okay, so this is the YC, and A is what? A is this projected area. Okay, and W is what? W is the specific weight of this fluid. So in this case we can easily calculate what is the force here, and obviously this force is going to be horizontal force. So we know what is the horizontal force, and this horizontal force will act obviously at the center of pressure of this projected area. So obviously this over here, this FH is acting, this FH is acting at YP according to our previous information. Okay, now this is the horizontal force, so we calculated this one. Now to calculate the vertical force, we have to calculate the weight of water above this curved surface. Okay, we have to calculate the weight of water above this curved surface. So let me draw it again here. It will take a little bit time, but diagram is consistent, so I am drawing it again here. So just little bit time, just a minute. Okay, so this is our curved surface. This is our curved surface, and around here is the free surface of fluid. Okay, so to calculate the vertical force, we have to calculate the weight of fluid above this curved surface. Now I think over here, this is the column of fluid above this curved surface. So let we are marking this point. Let this is A, let this is B, this is C, this is D, this is E, this is F, G, H, I, J. Okay. Okay. So in this case, we want to calculate the vertical force. So vertical force will be equals to the weight of the fluid held by this curved surface above this one. So obviously in this case, this much of volume of fluid this is holding this much of volume. Okay, this is holding this much of volume. So I think in this case we can calculate this weight of fluid here. So we can say that there is weight of this fluid will be equals to specific weight of fluid into volume. So volume will be this much. This is the volume, and we can multiply this volume to the specific weight of fluid, and then we can calculate this weight here. Okay, so this weight is equal to the vertical force. So this vertical force is acting in downward direction for this case. Now this FH is acting in this horizontal direction. So as we know the FH and FV, we can easily calculate what is FR, that is the resultant force. So that FR will be equals to FH square plus W square. Okay, in this case this W is what is actually this is FV here. So the generalized formula is this one, that is FR is this one, and now in this case I am taking this case. So let's understand this concept by one numerical here. So let we are saying this is the quarter of some circular plate. Okay, I'm taking some circular plate here, and this is completely submerged in fluid. So let here I'm saying this is completely submerged in fluid. So let this is just a minute, this one, and obviously this is going here, and this is the free surface of water here. Or let okay, I'm saying this is water here, so this is water here, and let we are saying the radius of this one is, that I'm saying radius is 1 meter. Okay, and let there is some length also. So in this case that I'm saying the length is 5 meter. Okay, so radius is 1 meter and the length is 5 meter here. So this is completely submerged in this water, and I want to calculate the hydrostatic force on this curved surface. And let this top edge of this plate is, that I'm saying this is 2 meter below. Okay, so first of all we will calculate the horizontal force component. So we can calculate the horizontal force component by calculating the force due to the pressure that is acting on this projected area of this plate. So what is the projected area in this case? The projected area in this case is actually this rectangle. Okay, when you view from this side, you will see this rectangle is the projected area of this plate. So obviously in this case, the height of the plate is 1 meter, that is equal to the radius, and length of this rectangle is 5 meter, that is the length of this plate. Okay, so this is 5 into 1. So first of all, we will calculate what is YC here. So I think as this is a rectangle here, so this is the center of gravity of this one, and for rectangle the center of gravity will be half. So this is going to be 0.5 here, and this is below 2 meter. As you can see here, this is below 2 meter. So the YC in this case will be equals to 2 plus 0.5, that is 2.5 meter. Okay, this is our YC. Second, what is the area? Area of this rectangle will be equals to 5 into 1, that is 5. So this is 5 into 1, that is 5 meter square. Okay, we know the area, and the specific weight of water, we know this is 9810 Newton per meter cube. Okay, so the horizontal force will be equals to WAYC. So this will be equals to, just a minute, this will be equals to, so we can say that this is 9810 into 5 into 2.5. So this value will be equals to 9810 into 5 into 2.5. So this value is going to be, this is 122,625 Newton. So this is the horizontal force, and this is acting towards right. This is acting towards right here, and obviously this force is acting at the center of pressure. Okay, this is acting at the center of pressure. So this is our horizontal force. Okay, so what is the vertical force? So vertical force will be the weight of the fluid held by this plate above this one. Okay, so vertical force FV will be equals to the weight, and we can calculate weight will be equals to specific weight of water into volume. Okay, so this one, then I'm dividing this volume in two parts, one for this quarter of cylinder and second of for this rectangular part. So let I'm saying this is volume 1 and this is volume 2. Okay, so what is volume 1? So I think this is quarter of some cylinder, this much of part, this is quarter of cylinder. So we can write this will be equals to 1/4 of pi by 4 d diameter. Diameter is, I think in this case the radius is 1, so diameter is 2. So pi by 4 d square into h. Height of in this case is 5 here. Okay, so this is our volume. So our volume is equals to, just a minute, so this is going to be pi by 4 by 4 divided by 4. So this is 3.9. This is 3.93 meter cube. Okay, so this is our volume 1. What is our volume 2? That I'm using this space here. So volume 2. So volume 2 is, I think this is rectangle. So this is a block here, a block of water. So I think in this case the volume is going to be 1 into 2 into 5. So this is 5 into 2 into 1. So this is 5 into 2 into 1. So this is going to be 10 meter cube. So the total volume is going to be Here this will be equal to 10 plus this one, so this is 13.93 meter cube. This is the volume. Now I think we know what is the specific weight of water here. Okay, so here, so in this case, the vertical force is equals to specific weight of water is 9810 into volume is 13.93. So this is going to be 13.93 into 9810, that is 136653.3 Newton. Okay, and this is the vertical force, and obviously this is the weight of the water. So this is acting in downward direction, so we can say that this is acting in downward direction. This is the vertical force. So we get the horizontal force, that is 122,625. This is going to be this one. Let I'm converting this one in terms of kilonewton, so it's easy for it. So this is 136.65 kilonewton, and this is 122.625 kilonewton. Now we want to calculate the resultant force. So resultant force Fr will be equals to the square root of, so this is Fh square. So Fh square, let I'm saying this, so this is 122.625 square plus this is 136.65 square. So this is our resultant force. So this value will be equals to, so just a minute, so this is 122.625 square plus 136.65 square whole root. So this is 183, this is 183.603 kilonewton. Okay, so this is our resultant force. And what is the direction of resultant force? So obviously we are doing vector sum here. So from here, this is Fh, this is Fv. So we can say that this is the direction of our resultant force. Okay, this is the direction of our resultant force. So here I'm drawing that this is our Fh, this is our Fv. So in this case, the resultant force is going to be like that. If you want to find out the direction, you can also find out the direction. Let if I'm saying this is theta here, so you can say that there is, in this case you can easily calculate what is theta here, because we know what is the value of Fr, and we know what is the value of Fh, and we know what is the value of Fv here. Okay, so I think the point is clear. So in the next lecture we will start the buoyancy, and I hope you like the lecture. So please subscribe the channel and comment your doubts and share the knowledge as much as you can. Thanks for watching. Thanks a lot. See you soon.